So, so good afternoon. I'm Qingjian, and today I'm going to present the question 3 of our CBT, Theory CBT. So for question 3, the question is a claimed count distribution can be expressed as a mixed Poisson distribution, and the mean of the Poisson distribution is distributed as below, as a table shown with different probability and different lambda value. And inside the probability, we got x and y, two unknowns. And you are given the variance claim count is 31.0115. I need to compute the probability of the claim greater than 20. So we got x and y unknowns. So first of all, we let x and y both equal to 0 first. And in the question, we know that n given lambda is a mixed Poisson distribution. So to find the probability of n given lambda, we can use this formula, which is the Poisson distribution formula, PDF. We need to multiply the probability of lambda given lambda. What does it mean? It means when n equals to 0, lambda equals to 2. When lambda is equal to 2, the probability of it is 0.29. So we need to use 0.29 multiply the exponential power minus 2 over 0 factorial, multiply the 2 power 0. So we can get the probability. So we list down all the combination of n and lambda. For example, like I said just now, n equals to 0, lambda equals to 2. We also got n equals to 0, lambda equals to 4, and others. We list until 20, since we need to find the probability of n greater than 20. By using Excel, this is the table that I provided. When n equals to 0, lambda equals to 2, the value is 0.0392. And when n equals to 0, lambda equals to 4 is 0.0035 and others. But you need to know that the x and y value is 0. So that for 21 and 22, lambda value is all 0. So we given the information that the variance of n is 31.0115. So to compute the variance, we need to compute the first moment and second moment first. For the first moment, expected of n, we know that is the double expectation of n given lambda, which is also the expected of lambda. So the expected of lambda means that the formula is lambda multiplied probability of lambda given lambda, which is for lambda equals to 2, multiply 0.29 plus lambda equals to 4, multiply the probability of lambda equals to 4, and sum all together. For the second moment, we can use the relationship of Poisson distribution between the variance and the first moment. So for the second moment is the variance plus the first moment square, which is lambda plus lambda square. And don't forget, we need to multiply the probability of it. After that, the variance of n is the second moment minus the first moment square. After compute, the variance of n that I computed is 28.342775. However, the question given us the variance value is 31.0115. The value is different. So which means that the x and y value is not 0. So we need to adjust the x and y value in order to make it become 31.0115. So how to do this? We need to use solver function to fulfill the criteria of variance equals to 31.0115. And also don't forget that the total probability of lambda must equal to 1. So I'm going to show you how to use the solver function by using Excel. So first of all, when x and y is equal to 0, the variance is 28.342775. To make it become 31.0115, we click the data solver. We set the objective is the variance and become the value of 31.015. By changing cell, F4 is x and F5 is y. We need to add the constraint, which is the total probability of the lambda value is equals to 1. Initially, it's 0.985 when x and y equals to 0. After that, we click solve. The value of x and y will be auto-generated. And then the variance value become 31.0115. And also total probability is 1. So it's fulfill our criteria. After that, we need to compute the probability of n equals to n from 0 until 20. So for n equals to 0, we sum all the possible value of probability of n equals to 0 given the different value of lambda. Lambda equals to 2, 4, 6, etc. From the table given 2, 4, 5, 8, 10, 13, 14, 16, 17, 20, 21, 22, 24. All the probability of it, given that the n equals to 0, we sum all together. Then we will find the probability of n equals to 0. For n equals to 1, also the same until 20. After that, we need to find the probability of n greater than 20. We can simply just use the relationship between lesser or equal to 20 and greater than 20, which is 1 minus probability of n lesser or equal to 20. So the value is 0.024064735. By using Excel, I add one more column behind this. So the probability of n equals to 0 is the summation of this line. For n equals to 1 is summation of this line. We do until 20. So the probability of n greater than 20 is 1 minus the summation of this. We got the answer is 0.024064735. And it's our final answer. So thank you and hope you enjoy and learn something from it.